is root locus? We went on to the introduction of root locus. Now let us see what are the rules that are needed to construct a root locus. Okay. The first rule is, rule number 1 says, root locus is symmetric about real axis. So this is the first major thing which we need to know whenever we start constructing a root locus. So after the completion of root locus, we can clearly check whether the root locus is symmetric about the real axis, which means that, so if I draw S plane, so this is sigma and y axis will be j omega. So as the first rule tells, it is symmetric about the real axis. So this is our real axis and this is our imaginary axis. So for example, if I take a root locus which is something like this, so we can clearly see here the upper part of this real axis is going like this and it is crossing at 2. Similarly, the lower part is also crossing at 2. So if I fold this root locus on this root locus, they will be symmetry. So this is the first rule. Okay. Along with this, it tells that always a root locus starts from a pole and terminates at zero. So this is nothing but rule number 1, that is, root locus is symmetric about real axis, and then always a root locus starts from a pole and terminates at 0. So moving on to rule 2. So in rule 2, what we are doing is, we are trying to find out the number of poles and zeros present in the given transfer function and their locations, that is, finding the number of poles and zeros in the given transfer function and we also try to find out their locations. Okay, so this is nothing but rule number 2, that is, in the given transfer function, so how many poles and zeros are present and where are they located. So that is done in rule 2. So now let us take an example and see how rule 2 is done. I have taken an example, so that is the open loop transfer function g of s into h of s, which is equal to k divided by s into s plus 4 into s square plus 4s plus 20. So we all know in the transfer function, in the numerator we will have zeros and in the denominator we will have poles. Now looking into this, according to rule number 2, I need to find out the number of poles and zeros in the given transfer function. That is the first criteria. So always the number of poles are denoted by P and the number of zeros are denoted by Z. So looking into the transfer function, as there is no zeros in the numerator, no terms in the numerator, it clearly indicates the number of zeros present in the given transfer function is 0. Okay. Coming to the denominator, so which indicates the number of poles, we have, this is order 2 equation. So here we get 2 poles, 3 and 4, totally we get 4 poles. Therefore, in the given transfer function, we have 0 number of zeros, that is, we don't have zeros, and we have 4 poles. And later I need to find out their locations. In order to find out their locations, what I need to do? I need to equate each and every term in the denominator to zeros. Okay. So if I equate this to 0, S is equal to 0, which means that one pole is located at S is equal to 0. We have 4 poles, out of which one is located at 0. Okay. Now equating the second term, S plus 4 is equal to 0, gives us S is equal to minus 4, which tells that one more pole is located at minus 4. Clear? Now moving on to the third term, if I equate S square plus 4S plus 20, if I try to find out the roots of this equation, the roots of this equation is nothing but equal to minus 2 plus 4j and minus 2 minus 4j. So we had 4 poles and the locations of the poles are 0, minus 4, minus 2 plus 4j and minus 2 minus 4j. Similarly, if we had any zeros, that is if we had any term in the numerator of the given transfer function, in the similar way I need to equate that particular terms to 0 and I need to find out what will be the roots, that is what is the value of S. Here we don't have 0, so the value of 0 is equal to, Z is equal to 0. Now if I plot the same thing on S plane, so how can I draw that? So let me draw it here. So 0, 1, 2, 3 is a sigma, minus 1, minus 2, minus 3, minus 4, minus 5, minus sigma, and here it is 1, 2, 3, 4, 5, j omega, minus 1, minus 2, minus 3, minus 4, minus 5. This will be the negative imaginary axis, that is minus j omega. Now we all know poles are indicated or denoted by a symbol cross mark and zeros are indicated just with a 0 mark as usual. Now let us start writing the location of poles on the S plane. Okay. So the first pole is located at S is equal to 0. So this is our S plane. First pole is located here. Okay. So the location of second pole is at minus 4. So it is here. And the location of third pole is at minus 2 plus 4j. Minus 2 plus 4j comes here. And the fourth is at minus 2 minus 4j. Minus 2 minus 4j. So this completes rule 2, that is finding the number of poles and zeros in the given transfer function and finding their locations. First try to find out number of poles and zeros, then their locations, then plot all the data calculated onto the graph sheet. Okay. This completes rule number 2. Moving on to rule 3. In rule 3 what are we doing is, we are trying to find out whether the real axis is part of root locus or not. In order to do so, what we need to do is, I need to take the sum of poles and zeros located only on the real axis. If the poles and zeros on the real axis is odd, then that particular portion of the real axis will be part of root locus. If it is even, it is not part of root locus. For that, how to do? So this is our graph sheet. So on the real axis, I need to consider the sum of poles and zeros. So this is our extreme pole, which is towards the left hand side of S plane. So on this pole, I will consider a point towards its left hand side. So that is, I will consider a point here. So now at this point, if I stand and look towards right hand side of the real axis. What is the number of poles and zeros we have? We have only 2 poles located on the real axis. I need to consider the poles and zeros located only on the real axis, nowhere else. Okay. Since it is 2, we all know 2 is an even number. If it is even number, it is not part of root locus. Therefore, from minus infinity to minus 4, the real axis is not part of root locus. Okay. Similarly, so this pole is done. Now I will stand towards the left hand side of this pole. I will stand here. Now I will look towards right hand side of this particular point. I am standing here and looking towards right hand side. Now since I am looking towards right hand side, the sum of poles and zeros on the real axis is 1. 1 is an odd number. If it is odd number, we all know it is part of root locus. Therefore, from minus 4 to 0, the real axis is part of root locus. So, like this, we try to find out which portion of real axis is part of root locus. So, we all know what do we do in rule number 3? We check for sum of poles and zeros on real axis. If the sum is odd, then real axis is part of root locus. If the sum is even, that is sum means sum of poles and zeros located on the real axis is even. If the sum is even, then the real axis is not part of root locus. Okay. So this is rule number 3. So from the example, from the figure, what is the conclusion? From minus infinity to minus 4, the real axis is not part of root locus. From minus 4 to 0, the real axis is part of root locus. Like this, we need to complete rule number 3. Hope rule 1, 2 and 3 are clear.